We're going to turn our attention now to the matched pair design, which is another design for within subjects, and it is mathematically and statistically equivalent to the pre-post design, although as you'll see, it has a different intended purpose. But I'll also show you that you analyze the data the same way as you do with the pre-post design. So in terms of statistical learning, really all you have to learn different about this design is how the design works. Everything you learn statistically to analyze pre-post data, you can use for the matched pair design. So let me show you how this works. This time you do have a comparison group, so you can have a treatment and a control. But what you do is you start by matching people up, and you have to match up on some extraneous variable. So I've kind of set it up here for a little example. Here I've got 6 students, and here's the grades that they're making in their class at the time. Let's say that this is an algebra class. And so you have some students who are making A's, some making B's, some making C's. So what makes it a matched pair design is that we match up students based upon an extraneous variable. And in this case, the extraneous variable I'm going to use is their current achievement in the course. So if I was to start matching them up, I'll take this student here's got an A, and I'm going to match that student with this student here who also has an A. So they're going to be matched up. Then I'm going to take this student here with a B, and I'm going to match them up to this student here that has a B, and finally for the C's. Okay, so you match. So this is using current educational achievement. But let's suppose we were doing a medical study. You could match on the basis of how severe their particular disease is. So if you were looking, for instance, let's say you were looking at high blood pressure. Well, some people have just barely high blood pressure, and others it's very high. So you could match based upon just how high that blood pressure was. Let's suppose that you were doing a study of physical endurance, and you want to see if you can increase endurance with a particular intervention. Well, you might want to start by matching people up on their current endurance before you ever start the study. Okay, so now we're going to have in this study, we're going to have a control and we're going to have a treatment. So if I wanted to put one member of each match in the control, what I'm going to do to make it a true experiment is I'm going to choose them at random. You could do this with a coin flip. So let's suppose that this person here was designed to have the treatment. So I put them over here. And this person here was designed to have the control. I'll put them down here. And now in B, let's say this one was chosen at random for the treatment, and this one for the control. And then this one here for the treatment of the C's, and this one here for the control. So now I have my 2 groups, my treatment condition and my control condition. One group, say, is going to get a standard educational intervention, and the other group is going to supplement their education with Khan Academy. So these individuals over here are going to receive the regular intervention, the regular teaching from the teacher, but they also are supposed to go and see some videos on Khan Academy and see if it helps them even further. Whereas these folk over here are in the control group, they're just going to get what they always have had. Okay? Well, you can see already that one of the advantages here for this design is that we've kind of equated these 2 conditions. Remember that a concern that we always have in behavioral and social research is that it's extraneous variables that are making the difference. If we randomly place people into conditions, just totally at random, you could end up with all the high achievers in one condition, or at least a higher proportion of high achievers in one condition. But here, we've prevented that because we matched on achievement. And so we know we have B students in each condition, C students in each condition, and A students in each condition. So that's one of the powers of this kind of design. So we make observations of units that have been paired on a relevant extraneous variable. In my example, the relevant extraneous variable was how well they were doing in the course before we ever started the study. Then each member of each pair is randomized to one of two conditions. The explanatory variable here is no longer time like it was with pre-post. The explanatory variable here is condition, just what we're used to, having a treatment and a control. The response variable is a measure of the difference in outcomes between the members of the pair and can be either quantitative or categorical, just like we talked about before. So let's bring up a little spreadsheet here. Let's say now that we have the control condition and we have the treatment condition. And let's use that same example that I was showing you over here with 3 in each condition. So let's now say that we have done a unit in algebra. And the only difference between those in the treatment and those in the control is, in addition to their regular teaching on the unit in algebra, that those in the treatment also watch that same unit. They watch the videos in Khan Academy. Okay? And so now they're given a test on that unit. And so I'm going to put in a few different scores on that test. Let's say it's out of 70 points. So here are a few scores. And let's suppose that Khan Academy actually was helping. And so as a consequence, the people in the treatment condition ended up getting better scores than those in the control condition. Now, what makes this different from a one-factor study that we've looked at in the past is that these students are matched. That 50 and that 68, those students, before they ever went into the control and treatment group, they were all getting C's, or both getting C's. And so they were matched up. Remember when we did our one-factor analysis of variance, one of the conditions for valid inference was that the individuals in each condition were independent of each other? Well, that's not the case here. These two individuals, this one person got a 50 and 168, but they're not independent of each other. They're related because they were both getting a C in the class. These two individuals are related because they were both getting a B in the class. And these two individuals are related because they were both getting an A in the class. Now, this pair of individuals is independent of the next pair of individuals, okay? But within a pair, they're matched. And so, unlike the one-factor design we've studied in the past, we cannot say we have independence across conditions. We've actually created a purposeful correlation among the treatment and the control scores. Let's go ahead and look at that difference, and we can either look at it quantitatively or we can look at it categorically. Let me read this in. I'll just call it matched and read in this file, which, let me make sure I get the name right, is matched pair.csv. Okay, so here I have now 3 observations of 2 variables. Okay, so if we go back to what this says, we can look at the difference in outcomes between the members of the pair. So let me go ahead and call that matched diff, which is going to be matched treatment minus match control. And I'm doing it in this order so that positive numbers will mean that the treatment's working. And now if you looked at match diff, you can see 18 points higher for the treatment condition, 10 points higher, and 7 points higher. Notice that this is just the exact same thing when we did this over here with pre-post. When we did this with pre-post, we were just taking post minus pre. And when we're doing it in match pair, we're taking treatment minus control. That's what I mean, that even though the design is different, they're statistically equivalent. And similarly, if I wanted to have something I called matched improve, then I could say if the matched treatment is greater than the matched control, then let's call them improved. And if I do that, oh, I forgot to look at this. It's supposed to be an assignment operator, and it's just a less than sign. All right. Okay, and everyone improved, and so we've got the categorical data. So we can either analyze these data by looking at mean improvement, or we could look at the data by looking at the proportion that improved. In some studies, the same person can be placed in both conditions and be his or her own match. So let's look at that in the next video. I'll see you then.